from my own perspective, I think that we need to find ways to work on international levels to set up marine protected areas and stuff like this, and not just keep it at the kind of national level per country. We need to start thinking globally, because copepods and other animals, they don't really care about the borders that we have. Everything, how we live and how we view everything is all from a human perspective, but animals don't work that way.
My guest this week is Dr. Jordan Grigor. Jordan is a marine biologist and he is a blogger. He has a bachelor's degree in marine science with Arctic studies from the Scottish Association for Marine Science. He's got a master's in climate change impacts and mitigation from Heriot-Watt University, and he's also got a PhD in marine biology and bio-oceanography from the Université Laval in Quebec. Currently, Jordan is an oceanography and data tutor, data analyst, and he is a blogger, and he blogs about his experiences with having autism. Jordan, welcome to STEM with Mr. N.
Hi, Mr. N. And nice to see you. Thanks for bringing me on the show.
No, thank you for being on. Can we just start with what is marine biology?
Yeah, so I think marine biology is a very interesting thing to work on and study. It's basically the study of life in the sea and in what's called marine ecosystems. That's the aquatic ecosystems that are salty. So if we study marine biology, we're interested in the animals, the plants, the fungi, bacteria, and other organisms that live in the seas. And there's a specific focus on how they can live there and how they can survive and continue their populations.
And obviously I said there in the introduction that you're a marine biologist, but then said currently you're an oceanography tutor. So what is oceanography, and how does that differ from marine biology or link together with marine biology?
Yeah, that's a good question. And there's quite a lot of people that are confused about the difference between the two. Marine biology is part of oceanography. So oceanography is kind of a larger discipline, which actually comprises lots of different sciences. So anything that's related to the study of the oceans can be comprised or described as a subject within oceanography. You've got like marine geology, physical oceanography, chemical oceanography, anything related to just studying the sea in general. That would be oceanography. Marine biology is just part of that.
Okay, and then I also noticed that as part of your studies in marine biology, so you've gone from having the oceanography umbrella down to marine biology, and then within that you specifically studied in the Arctic, in Svalbard, I believe. Why did you want to study in the Arctic?
Well, that's a good question. The Arctic is one of these environments that always kind of fascinated me as a kid. The opportunity came when I was doing my bachelor studies to spend 1 year in Svalbard and specifically study marine biology, how animals in the Arctic Ocean are able to live there. That's somewhere where a lot of people could definitely not imagine living, in the Arctic, for a bunch of reasons. The cold is an obvious one, but something that happens in the Arctic is the period of midnight sun and the period of polar night. So in the summertime, it's just perpetual sunlight. And in the wintertime, for a certain number of months, it's just perpetual darkness. I was fascinated by how animals such as plankton and fish are able to deal with that. How are they able to find the food that they need to find? How are they able to reproduce? And there are answers to those questions. I was able to work on those during my time there.
So just to dig a wee bit deeper, because I've got a bit of knowledge about this, but people watching might not. So you were saying specifically looking at plankton and how they would deal with things there, or mating would happen there. Why is that long period of darkness so different for how it would affect plankton, for example, than elsewhere in the ocean?
Well, the Arctic can be called, or the Arctic Ocean can be called, an extreme environment, specifically in terms of food. So what happens in the summertime is you have, the spring and summer really in the Arctic, you have great conditions for phytoplankton that's the kind of plant plankton, to bloom in the seas. And you can actually, I'm sure you've seen satellite photos where the ocean surface in different places can appear green. That's generally what's called a phytoplankton bloom. That phytoplankton is then consumed by other plankton animals, such as copepods, and then the copepods are consumed by other animals still, like chaetognaths and fish. The fish are eaten by seals, and the seals by the polar bear. There's generally this kind of flourishing of activity at every single level during the spring and summertime, but it really dies down after that. And in the wintertime, there isn't that much phytoplankton available for the herbivores to eat, and that does affect everything else in the food web. So it's very important that the animals are able to do something in the wintertime. And for a lot of animals, it's hibernate, and for other animals, it's stop feeding on phytoplankton and find something else.
I'm glad we dug down into that, because I know food webs is something that a lot of people in primary schools certainly look at, and I have looked at with the Arctic, but I've not gone into that much depth because I didn't know that there was that much detail to it. So I'm glad I dug into that. So
that's the thing, is a lot of people don't even know the names of some of these creatures that live in the Arctic and in other oceans. You know, there's a lot of cool names of animal plankton, okay? That's called the zooplankton. So the zoo is obviously somewhere where you go to see animals, and we call the animal plankton the zooplankton. That comprises jellyfish and lots of jelly type animals. You know, we've got things called comb jellies, got things called sea gooseberries. We've got things called sea angels. And these are all just cool names that we've given to, our scientists have given to these creatures.
And obviously, you know, we know, they always say we know more about space than we do about our oceans, and have explored more about space. Is that what attracted you to oceanography and marine biology, or was there something else that drew you in that direction?
I think that was probably part of it, but the number one thing that got me into it was becoming a scuba diver. Because if you, I don't know if you scuba dive yourself, Mr.
I have done a couple of times, but I wouldn't call myself a scuba diver.
Well, you probably did it abroad in a hot country or something.
I did.
Yeah. I mean, obviously diving in the Arctic is a whole different thing, and I'm not really attracted to that, but I have a friend who does that as a job. If you go in the water, you know, it's like entering a whole new world, you know, and you see things. Like I said, you don't need to go far to see these things. You could see many of these creatures in waters close to where we live. Sea anemones, jellyfish. And when I saw those creatures, I was like, I want to know how they're able to live here. That's what really got me to think about pursuing it at university. I mean, it seems like such an interesting past that these creatures have had. I mean, something like a sponge. It's one of the oldest animals in the world, but it's still, or a continuation of the sponge still lives today. So it's anything that lives today and has persisted for millions of years has obviously done it pretty well. And it's that I was curious about.
And prior to becoming a scuba diver and getting that interest in animals, were you already interested in STEM subjects, or was it just the scuba diving that then led you in that direction? No,
that happened around the same time as I was doing advanced tower biology in school. Probably I really considered doing it at university during higher biology in S5. And because at that time I had a good science biology teacher, and I got to do a project working in a local stream. So you could see what direction I was going in already. And it was looking at the animals in the stream at that point. I think the teacher you're going to have in school for science subjects does make a difference.
And is that what made a difference with you? Obviously, by that point, you were doing your higher biology, so you were already invested in science. But going further back then, was it teachers that got you interested in science?
Well, that is a really good question. And I think I've talked about that recently in regard to the autism. Like, I do think that from day one, I've always been into numbers, and I've always been working within a scientific logic, scientific framework. Like, instead of just taking something you're told to be 100% true, I would always try and research it more and look into facts. and hear both sides of the argument. So that mentality started for me from very young. And that's a very helpful thing to do if you want to be a scientist.
And we're going to come back to the autism in a minute, because there's something else. There's lots of bits you're saying that I want to dive into a wee bit. So we'll come back to the autism in a minute. But going back to the Arctic animals, you were obviously talking there about during the winter they need to find some other way to survive. But your master's in climate change, its impacts and the mitigation. Climate change is obviously also going to have an impact on not just the Arctic animals, but ocean life in general. Can you say a bit about what impact climate change is having, and then what we as a species can do, or even as individuals can do to help improve things for the ocean?
Yeah, the problem is that climate change is affecting every single one of these creatures that we talked about before, and all the others, in probably about 50 different ways, because the animals have adapted to their environment. You know, there's animals that if they lived in the Arctic, or animals that live in the Arctic, you couldn't just take that animal out of the Arctic and place it in Peru, you know, or place it in the Maldives. It's not able to deal with the change in temperature, as well as a change in other things, like probably the sunlight and things like this. With Arctic animals, some of them are being replaced by animals that are other plankton that are moving from the south up north now, because it's getting warmer up north. These animals from our countries are able to now move into the Arctic, and a lot of those animals can outcompete the ones that live in the Arctic, so they can oust them. They might be more generalist feeders. They might be bigger and are able to compete more for resources. And that would be bad for the animals that have lived in the Arctic this whole time. And then bad for the animals that eat them.
So if, because we were talking about the food web earlier and the plankton, and then it gets eaten, and then there's always a bigger fish, and then you get to the polar bear. So if plankton is moving up into the Arctic, is there a difference between the plankton that Arctic animals would not be able to eat it or have an issue with it? Or is it more that as that plankton moves, what further south eats that plankton is also moving with it?
Yeah, it's both of those things. I mean, I'll get back to the first question that you raised. There's birds called little auks. Its name is Ali Ali. And that bird only feeds specifically on larger copepods. So the copepods they're basically crustaceans. They're kind of in the same group as crabs. And this is actually copepods. People don't know this, but it's estimated that the copepods might be the most abundant multicellular animals in the world, because they're all over the oceans. You know, literally, if you were to put a net in the water, or even a spoon, you'll pull out a copepod. But a lot of people won't even know what they're looking at. So that's why you need the help of a scientist to help you identify them. But this bird I'm talking about, the little auk, that only really prefers to feed on the larger juicy copepods, because those copepods are filled with fat resources that help the little auk. It doesn't like to feed on the smaller copepods. Unfortunately, the copepods that are moving north from our country to their country, they're way smaller than the ones that the bird likes.
And obviously those fat reserves are then going to be needed to survive the harsh climate and the colder weather. So it's a constant knock-on effect then.
Fat is the #1 resource for animals in the Arctic. It's the feeding on and building up your fat reserves in the summertime that keeps you going during the wintertime. And if you can't do that, you might end it.
And is there anything specifically that that can be done to protect the ocean, separate from just trying to mitigate climate change as a whole? Is there anything specifically that can be done to help the oceans?
I mean, as a researcher, we spend quite a lot of our time, you know, trying to document what's going on in these environments. So we can see that an animal is moving north, changing its ecosystem. That's kind of the main part of what a scientist does, a researcher. So they don't always want to go into the kind of like the suggesting massive big picture that is to do with politics. It gets a little bit difficult, but I do have my own opinions about that. I feel that from my own perspective, I think that we need to find ways to work on international levels to set up marine protected areas and stuff like this, and not just keep it at the kind of national level per country. We need to start thinking globally, because copepods and other animals, they don't really care about the borders that we have. Everything, how we live and how we view everything, is all from a human perspective, but animals don't work that way.
And there's a lot, and obviously there's a lot of organisations that are trying to do that as well and pull things together. And I appreciate such a candid response, and also a bit of insight into researchers just look at the data and don't get involved in the bigger picture. So that's a good thing to note.
But they're also the number one people that people go to when they want the political arguments, which is a bit difficult because I'm not associated right now with a university. I can say this stuff, but I know people that are really careful that they have to check with their communication departments and stuff first,
Yeah. Well, that's good that you were able to give your opinion as well as obviously giving us that insight into researchers and what can affect them. So now I'm going to go round to the autism part of what you were saying about thinking about that in your past. Now, I understand from speaking to you that you have only recently been diagnosed. What led to you receiving that diagnosis just fairly recently? I
think that the COVID situation and lockdowns really put things into perspective for a lot of people. It was probably the first and longest period in my life when I had to actually sit down, take a break and start processing things. And it was also the first time that I spent, since I was 17, several months around my family, around my parents, because I moved away from home when I was 17. And, so I think if you follow a certain path, you can get into your own habits and it's fine, it works for you. But when you start integrating with more people around you, they start noticing things and they call you out on it. And I can see now, going back, that I get very obsessed about certain subjects. Some of those subjects can be helpful and useful, and other times they can be bad for your health.
And how do you feel now that you have that diagnosis and you look back on your past? How do you feel that impacted you through your education, either positively or negatively?
Yeah, that's a tricky question, because I do have a little bit of bitterness that I wasn't detected earlier, because nowadays everybody says, oh, it's so obvious. Even you speak to a mental health nurse and tell her that you got diagnosed with autism, but none of these GPs and mental health therapists were even suggesting it before, and you need to be careful, because you could get diagnosed with other things, such as what I have had in the past, like anxiety, depression, obsessive compulsive disorder. And that is not, at least it wasn't in my case, the crux of the issue. Although those things were more symptoms of untreated autism. Autistic people can be really, really useful in society, to companies, to families, to themselves, if they can get diagnosed earlier, I think. And the main reason is so that they can communicate with their bosses, as well as everybody else in society, about the best way to help them succeed, instead of necessarily just thinking that they don't get on and it's their fault.
Yeah. And is that why you've started blogging about it, to raise a bit more awareness about, how it impacts your life and other people's lives? Obviously, being a spectrum, it's different for everybody, but is that what led you into the blogosphere, writing about it?
I used to do a blog when I was in Canada about the Arctic stuff, and it was like Arctic Animal of the Day and stuff. So I was always fascinated by science communication and being able to communicate something interesting to the public. I think that there's a lot more interest now in neurodivergence, as they call it, and autism. Because when we were younger, and we found out recently that we're about the same age, autism was not viewed in a positive light. The most kind of common comprehension of autism was like Rain Man, right? Instead, I've seen now that it's just such a range. I mean, I do have a question about the validity of grouping so many people together onto one spectrum, because my auntie's got autism, but she is, let's just say it's more like emotional regulation. rather than, focus on numbers, focus on data. There's companies, and I won't name them, but they specifically hire autistic people that are particularly interested in data analysis. But it seemed to me that I did have questions about whether they were why just target autistic people for that purpose? Because you couldn't really do that in many other groups in society.
But obviously you with being autistic, you are also a data analyst. So
that's the point, right? It's also, you don't have to be autistic to be a data analyst or vice versa. Yeah. You could be the most fantastic data analyst and not be autistic, and same way around. Likewise, you could have no interest in data and be autistic.
But you had said earlier that you were really interested in numbers when you were younger, and you attributed that to the autism. Do you think that is why you then continued down that path and into data analysis? Was that very early interest in numbers?
I mean, I've kind of concluded that the interest in numbers and addictions and obsessions are quite common in, let's say, high functioning autistic people, those with kind of a pretty decent IQ level. So that's really quite common. And all the greatest scientists of all time were autistic. But I mean, the idea is that the autism in these people's cases helped them to focus intensely on their subject. So if they had a specific science question that they were interested in, they didn't quit until they found the answer. And I'm a bit like that, right? But our society does not always appreciate that, because nowadays it's all about funding. And if you can get funding and not annoying your colleagues and being respectful in the workplace. And not all of those are particularly helpful to the autistic person that just wants to answer the question.
And is part of that the reason why you are doing your own thing as an oceanography tutor and data analysis, rather than being in academia as a university-linked researcher?
Yeah, I think that's the main thing. I applied for grants before to work on arrowworms, so that was what I did my PhD on. It's kind of like a jelly worm about that big. I was really interested in working on that, but it just couldn't get the funding. And you spend so much time in academia writing papers, applying for research funding, and the salary is nowhere near what it needs to be or should be for these people spending that time on it. Nowadays you can leave academia after the bachelor's, get into data analysis as a job and get paid 50 grand a year, maybe 60. I was working as a postdoc, which means after your PhD, for half of that money.
So that's been a very in-depth look at, marine biology, oceanography, what you've done, the autism blogging. We've learned a lot there about you, but something else I want to know about you is, do you have, or did you have, any STEM heroes as you were going through your qualifications?
Yeah, I do actually. That's a kind of good question. I've got two, okay? The first one is Jacques Cousteau, and a lot of people have heard of his name, and also of his sons, who got a lot of interest in, protecting the oceans. And you can read about them. I think his son's called Pierre, on the news quite regularly. So Jacques Cousteau was someone who really pioneered scuba diving, going back probably like 100 years now. And he was doing a lot of work from a young age on photographs, taking images of animals in the oceans in really, really extreme environments as well. Like, he went down on a submersible into really deep water. And we do that kind of stuff nowadays as scientists, using a submersible called Alvin. So scientists, not me, but scientists have gone pretty deep into the ocean. The deepest part of the ocean is the bottom of the Mariana Trench in the Pacific. And if you go down to those places, you can see crazy animals, like animals with massive eyes, strange heads. And we talked earlier about the adaptations that animals need to live in certain places. Those adaptations are pretty crazy in those animals. And it's really thanks to the work of Jacques Cousteau and other people before that we're able to do the kind of investigations that we're able to do now. And the other one is a female, actually, called Angeles Alvarino. And Angeles Alvarino She was from Spain, and she worked on zooplankton, and she discovered so many species. I can't remember how many, and I'm not going to quote, but I think it might be like 100 or something. And she really published so many papers, worked so hard on her field at a time when probably there wasn't that many females at her level in academia.
So if you get any advice for children and young people who are interested in the oceans or marine life and how they can pursue that forward into, their qualifications or into a career?
Yeah, well, I want to be someone who definitely vouches for a bunch of avenues for students to follow. Academia is one of them, but enterprise, business, and education are other avenues. Where I studied before, which was a place called the Scottish Association for Marine Science, these three things I just described were called the three pillars of science. So you probably need a bachelor's to kind of work forward on any subject in science for a career, but you wouldn't need a PhD necessarily to work in business or education. So depending on which pillar you're most interested in, that will help you decide how much studying you need to do at university.
So you spoke there about the different routes that students can go down or pupils can go down if they're looking to get into marine biology, and there was business was in there, but there was also academia. So what is the best way to be successful within academia?
I would say that probably one of the most useful things to do is to build a network and try to get to collaborate with other scientists that have the same interests as you. In oceanography, that's actually quite easy because we all know that every animal is sensitive to changes in the environment, physical, chemical. So you can bring chemists, physicists, and biologists all onto the same work, all into the same project. And sometimes these collaborators will be from your country or they could be from another country. This is building your network, and these people will invite you back onto their papers in the future. So you can end up working with them for maybe 20 years to come, 30 years to come. That's very common for people that stay in academia.
Are there any opportunities without going down the university route that you can be involved working with the ocean or marine animals through apprenticeships or other different routes?
There's a bunch of STEM organizations that want people to, do this. It's called what's it called? Like public science, yeah, community science.
Yep.
Basically, where you can go online and you can actually help researchers to identify photographs, to collect data on the weather, to collect data on the animals that live in their local stream, and actually contribute to research that way. Also, they can contribute to science fairs, and for their work experience at university, they could go into, for example, a charity or an organization that helps to clean the ocean.
And I know citizen science is becoming a lot more popular these days with scientists doing it because they can collect data from all around the world. So I'm glad you brought that up because that's a good opportunity for children and young people now to get involved with current scientific research, before they're even at that university level.
And they can see that they worked on a research project even in high school, which is cool. There's one called Plankton Portal, and Plankton Portal is a website where the citizens can help the scientists to identify plankton. And I think that they will gain a lot of knowledge from that, as well as feeling like they've contributed to potentially a research paper at the end of the day.
And there was somebody, although this is not an oceanography, there was, I believe, a Dutch woman who was doing a citizen science project about space, and she actually discovered something completely new through this project. I think they were identifying star clusters or something, and she discovered something never seen before, and it's now actually named after this citizen who is not a scientist herself. So you never know, people watching this, if you get involved in a citizen science project, you may be somebody that discovers this brand new thing and have something named after you, as well as just getting involved in research.
Well, think about what you said earlier. You know, we know more about the surface of the moon and potentially Mars than we do about the deepest parts of the oceans. You know, there are creatures out there that have never been seen and have never been identified. And one day they might be by one of your students.